Welcome to EDU World Space.
So oftentimes, theorems are incredibly useful because they allow us to take common application problems, common problems we run into in math, and be able to essentially use a formula or some theorem to simplify the idea of the problem. So what we see in this case is we're going to want to use theorem 10 in order to find the curvature of r of t being t squared j plus e to the tk. So we're going to want to write this in vector form. I just prefer it that way. So we'll have 1, 2t, e to the t. If you don't prefer it that way, you can always write it with the i's, j's, and k's, but it's really up to you. Then we take the, that would be the first derivative right there. Since this was t, this was t squared, and this was e to the t. So our derivative, like we just said, is going to be 1, 2t, e to the t. And then our second derivative of the vector equation is going to be 0 to e to the t. So with this, we want to find the magnitude of the first derivative. We see that's going to be the square root of 1 squared plus 2t squared plus e to the t squared. We know that that's just going to be 1 plus 4t squared plus e to the 2t. And then we must find the cross product between r prime and r double prime. So when we cross these, we'll end up getting, as a result, 2e to the t times t minus 1 negative e to the t 2. And we can just calculate that cross product by ourselves, just following the formula. Now we need to find the magnitude of this cross product. So once we find the magnitude of the cross product, we see that that is going to be all these terms squared and added together. So it will end up giving us the square root of 4e to the 2t, t squared, minus 8e to the 2t, t plus 5e to the 2t plus 4. Now with this whole thing is going to be divided by what we had earlier, which is this portion right here. And then the idea is underneath here, we cube this. So this will be the final answer because we want to plug in our magnitude. It's the magnitude of the cross product over the magnitude of r prime cubed. So this will ultimately be our final answer for the curvature of some given curve.